Welcome to the final video of this section, titled Adding VLAN Tagging. In the previous video we learned setting up port forwarding. In this video, hook it up to a switch that has VLAN enabled and create virtual interfaces assigned to the desired VLAN. Right now we have a rather simple network configuration. We have a single router with a public facing IP address on one interface and a private IP address on the second interface. But what if we want to have multiple private networks behind the route? Our first option in this scenario would be to add additional IP addresses to the internal interface. The IP command allows you to assign multiple IPs to a single interface with optional interface aliases like ETH0:0. This will allow you to assign IP addresses to systems behind the firewall within one of the few ranges and have them all route appropriately. The downside of this approach is that all the internal IPs exists within the same collision domain of the network. This has a few implications, including the ability to move systems between those IP ranges and potentially bypassing access control rules, as well as problems assigning addresses via DHCP due to the confusion about what address range to hand out. The second option would be to put a third network card in the router and then either plug the additional card into a dedicated switch or separate out the existing switch into multiple VLANs and plugging the new network card into a port on a dedicated VLAN for that network. The downside here is the additional cost of the NIC and then either the usage of an extra switch port or an extra switch. The third option is to configure the switch into dedicated VLANs and put the LAN side of your router into a port configured as a trunk. From there, Linux can be configured to use VLAN tagging to split your single physical interface into a pair of virtual interfaces and tag packets as appropriate, so that the switch automatically adds them to the appropriate VLAN. Now, how to do it. There are two steps required in order to use VLAN tagging on your Linux server. The first is to hook it up to a switch that has VLAN enabled, connected to a port which is allowed to act as a trunk. The specifics around how to configure a switch in this mode are outside the scope of this book, since they are specific to the switch itself. You'll want to find a managed switch which supports the 802.1q standard and consult its documentation for configuration. The second thing you'll need is to create virtual interfaces assigned to the desired VLAN. In our case, we're going to create two virtual interfaces which are assigned to VLANs 1 and 2. Now that they exist, you can treat them like normal network interfaces and configure them as we did in the section on adding a second network. Note that ETH0.1 is a naming convention, not a requirement at this point. You could instead choose to name the interfaces names wireless and wired if you wanted to. Let's see how it works. VLAN tagging, as defined by the 802.1q standard, functions as the Ethernet layer level. A standard Ethernet frame contains four fields: the destination MAC address, the source MAC address, the ether type or length field, depending on the type of frame, the data, the IP packet, and a frame check sequence, FCS. 802.1q works by adding a VLAN tag between the source MAC address and then the ether type or length field. A switch that supports 802.1q may have one or more network ports that are configured to act as a trunk. Trunk ports will accept VLAN tagged packets and will pass them along as appropriate. They will detect the specific VLAN tag, determine the appropriate VLAN the packet is destined to, and will deliver the packet to any switch ports that are on that VLAN. Tagged packets can even pass between multiple switches as long as they are properly configured. If a packet is received without a tag on it, it will have a tag added automatically, based upon the VLAN associated with the switch port it was received on. Brilliant! So we dealt with adding VLAN tagging. Here we are at the end of this section. Interesting, isn't it? In this section, we had set up the physical network, then configured IPv4. After that, configured IPv4 permanently. Next, connected two networks. Later we saw how to enable NAT to the outside. Next, set up DHCP. After that, set up a firewall with IP tables, then set up port forwarding, and finally added VLAN tagging. In our next section, we will deal with configuring DNS.